discussion about polygons. And I've started with our two basic polygons that everybody's very familiar with, that we're used to talking about, triangles and quadrilaterals. And then the other one that we're going to talk about as well is non-gons, okay, or n-gons. Everything that is five-sided or greater, because they kind of follow the same pathway and discussion pieces. These two are kind of special cases that we talk about quite a bit. There are other things special about these as well that we're going to talk about, but these two right here are the big ones. So when we talk about triangles, what type of, let me back up. A polygon, a special polygon, is a triangle. Under this we have different distinctions that we can make, right? So when we talk about triangles, we have different types of triangles. We have acute, okay? We have obtuse, and we have right. We don't have any wrong ones. But anyway, we also don't have any ugly triangles. They're all acute or obtuse or right. But anyway, the idea is that these are three different classifications for triangles. Now, we also have other classifications. So I'm actually going to come down here and re-split this again. We also have equilateral, I want to say isosceles, right? And equilateral triangles. So these are those pieces. Now, if something is an equilateral triangle, it's actually regular. You can go back to a previous video to talk about that idea behind it being regular. And then we say, well, which one of these would be that? Acute. A special acute triangle is a regular triangle, which means it's also equilateral. Those two right there go back and forth. The idea behind the tree diagram here are these are special cases as you move your way down. Okay? Special cases as you move your way down. A special type of triangle is an acute triangle. A special type of acute triangle is a regular triangle. A regular triangle, by definition, has to be equilateral and equiangular. An obtuse triangle cannot be equilateral or regular by sheer force of what's happening. We're going to talk in another video about the angles that are going on, but that's the idea behind them. Same thing is true about a right triangle. It can't be equiangular. And again, we're going to talk about more about that, why that's the case. But the short version of that is that if you have one right angle and all the angles have to add to 180, you can't have three angles in a triangle that add to 90, that are each are 90, and they sum to 180. That gives you 270 at the bare minimum. So it just can't happen that way. So when we talk about this process, we're talking about how do these pieces link to each other? What are the special cases? So let's talk about quadrilaterals. So, and then there's a whole other piece that we didn't even talk about with this, and that we first have to mention here with this. Concave and convex. Right? Concave, that's it. There's nothing really more we can talk about with that. We can have right angles in there and things like that, but it gets a little interesting. But anyway, convex are the ones that we're going to spend our time talking about. And under convex quadrilaterals, we have, what do we have there? Well, we have trapezoids. And trapezoids are different than, say, a kite. Right? And we also have rectangles. And we have a rhombus, right? So these are special types of convex quadrilaterals we have. And one of them that you think we're missing is a square, but that's actually not the case, because a special type of rectangle, notice what I'm saying there, a special type of rectangle is a square. It's also a special type of rhombus. So if something is a square, it is both a rhombus and a rectangle at the same time. But just because it's a rhombus doesn't mean it has to be a square, nor just because it's a rectangle does it have to be a square. And this one right here is our regular quadrilateral. So notice where that is in the tree, right? A quadrilateral can be convex. That convex quadrilateral can be rectangle or a rhombus, or it can be both a rhombus and a rectangle, which makes it regular. And we have a special name for that particular one, which is called a square. Right? We have a trapezoid. The trapezoid is convex, but it's not a rectangle. It's not a rhombus. It's never going to be regular because the sides by its sheer nature can't be equal. And the trapezoid, those opposite sides, you have one pair of opposite sides that are parallel, right? And that's the only requirement. That's it. But we do have special types of trapezoids. We have a right trapezoid. We don't have a wrong one, but we do have a right one. We have and that's just simply a trapezoid with one right angle. We have trapezoids that are isosceles, which means that the two legs of the trapezoid are congruent to each other. And then you have a scalene trapezoid, which just simply means that none of the sides are equal, but the two bases would still be equal to each other. And then you have a kite. Now, you will run across people who say, well, a special type of kite is a rhombus, right? And they'll say that means that a square can then be a kite, or vice versa, right? The idea behind a kite means that you have two sets of consecutive sides that are independently congruent to each other, right? So you have the top two, if you will, if you look at things about the traditional look of a kite. You have these top two that would be congruent to each other, and these bottom two that would be congruent to each other. So if by chance that all four were congruent to each other, it would indeed be a rhombus. Traditionally, though, when we say kite, we're referring that we have two sets of consecutive congruent sides, as opposed to a rectangle, which would have opposite sides would be congruent. In a rhombus, all four sides are congruent. So there's the distinction there. Okay. So then we get to n-gons. Once again, we have concave. That's about as far as we'll go with that. And we have convexed. Under convexed, we have regular and not regular. Right? These need to eat more fiber, yeah? So anyway, that's the thing we're referring to when we say convex. We have these two categories. Is there ways that we can subdivide these categories a little bit further? Absolutely there is. But these are going to be the major categories that we're going to deal with here. So quadrilaterals and triangles, the reason why we have those pieces broken down like that is because they are special in nature and the different things we can do with them, the different ways, different definitions we can attach to them, and different ideas behind them. These others, they start to follow the same general trend as we go through those. There's more to this tree diagram that we can definitely put in here, but this is a basis for us using that and going with it from there. I encourage you to build additional models or additional pieces to this to extend out this piece right here a little bit further and see what else, other ideas you can put and how else you connect some of these together. And yes, there are a couple pieces here and there that are left out. All right, enjoy. Take care.